now, to summarize, I want to start with the notation, since this also gives a nice summary of all of the forces we've talked about. And again, using the book notation, which is here, and I've listed some additional things that I think are equally clear over here, by using a consistent notation that everyone else is using, it really facilitates communication. So I guess in a way, I apologize for using a slightly different notation than the book. On the other hand, I think that there's a reason that, for instance, F sub n is preferable to just n vector. So the other thing, again, that I kind of want to stress is for the gravitational force, please use F sub g, where this can be a capital G or a lowercase g. I think that this is much better than just using g vector standalone, since g is 9.8 meters per second squared. That doesn't even have the units of force. So I really encourage you to do this as F sub g and not just g. Since we haven't yet talked about what the relationship is between gravitational force and 9.8 meters per second squared, but I sometimes see students making mistakes there, and I think clear notation will help remind you what the definition of all of these things are. Finally, you can use additional subscripts here to refer to different agents. And in some cases, you might want to replace it completely. So for instance, if we're talking about a push or a pull, obviously F sub p isn't very clear whether you're talking about a push or a pull in that case. So if you have a couch and one person is pulling and one person is pushing, you probably want to use maybe an initial from their name, not necessarily push or pull. That's up to you. And again, if you have a lot of ropes, you might want to use, T and then have subscripts representing each rope. Again, I like F sub T, but I recognize that you don't necessarily want to have tons of subscripts on one variable. So please think about your notation carefully. Again, we're covering this before we go into calculations, since having some of these basics down makes a really big difference later. So finally, most important from this video, every force has a specific type where, again, you can think about that as gravitational force, friction force, a push, a pull, well, usually tension, spring force, things like that. And I point this out because later when we talk about Newton's third law, we need to think about this very explicitly. So this is really important. So every type of force is identifiable. There is an agent. There is a thing that is causing the force. And again, that might be a person, that might be the earth for gravity, that might be a spring. Finally, and most importantly, there is an object. The object is the thing that we're actually calculating regarding, the thing that we're modeling, the thing that we care about. Right now, you only have one object to worry about, and every force, every individual force, is going to be of a specific type, have only one agent, and only one object. Now, one object can have multiple forces, which is fine. And again, we did define what net force was, which was the sum of them. But right now, what I'm most concerned about is the rules for an individual force. Second, forces are vectors. They have a magnitude and a direction, and we draw them in a very specific way where they are starting, not the arrow part, but the tail. The tail is at our object, and the tip is pointing away. Finally, you want to make sure that you're carefully identifying all forces acting on one object. I know that there's a lot of videos for these 3 sections here. This has taken a lot of time. But again, this is a really important step. And where people make mistakes frequently as we're working with forces is with these sorts of things, is failing to identify a force which is present, or imagining that there are forces present that really aren't. So there is those 6 steps that I went through, which you're encouraged to use, but make sure that you are at least putting time into that step.